this is Bruce McConnell of Locomotive Systems Training. I just got back in country yesterday from teaching a basic air brake class. It was a very good class. Anyway, today we're going to continue on with this. We're going to talk about episode 5, EMD engine design and components, and that's also listed as LSTV-005. All right, in review from last week, or the last time I was showing you this, we talked about a crankcase. Remember that an EMD engine does not support or have a block. It is comprised of a crankcase. That means they take a whole lot of individual pieces and they put them in fixtures so they don't move, and they bring in these massive welders and they weld all these components up. And when they weld all these components up, they make things like the airbox, the main lube oil galley, room for the airbox outside panels themselves, and also allows room for the, as you'll see later here, for the oil pan. So this is not a block. It is not cast one piece. It's a whole bunch of pieces that are welded together. And again, and by the way, just as a reminder, when I was doing this class the last time, we call these cylinder head pots, and that is exactly what they call them in the industry. But there is a technical term, I want to keep it honest, and these right here, where the power assembly fits, is called the cylinder head retainer. So there's 8 retainers on the left bank, 8 retainers on the right bank. Okay? All right. Now, I'm not going to beat this up because we talked about it pretty good, but I do want to talk about this bottom view. The bottom view shows the actual crankcase turned over on its side. You can see the airbox handhold inspection openings. They have the base rail here with the oil pan mounts to it. They have the liner pilot insert right here. And that lower liner insert combined along with this opening for the water inlets right here. Let me find one. Cylinder, nope, that's not it. Let me find it. Hang on. Here we go. Cylinder head locating and water discharge opening. That landmark right there and that lower liner insert is what probably aligns that EMD power assembly into this crankcase. Nothing else aligns it with those two items. One at the top of the power assembly and one near the bottom of the cylinder liner. Okay. With that being said, we also have some very key important areas here. We have what they call a piston cooling oil manifold. Yeah, all it is about a, I'm going to guesstimate and say here, and it doesn't matter, probably 1.25 inch, 1.5 inch pipe that runs literally from this end plate clear down to this end plate. Okay, I've got one here and I've got one here. And what these piston cooling oil manifold does is they allow oil to flow from the front end of the engine, which is located right here and also right here. And what it does, it allows oil to flow down both banks. And there's a piston cooling pipe that we'll see later on, where on every one of these locations, every power assembly has 1, 2, 3, 4, 5, 6, 7, 8. Okay, the right bank, and then of course we have them on the left bank. 1, 2, 3, 4, 5, 6, 7, and 8. And what that P-pipe or piston cooling oil manifold does, it takes that oil and comes through each bank. And what it does, it goes to what they call a piston cooling pipe, or what we in the trade call a P-pipe, and it directs that oil up to the bottom of the piston carrier. So we lubricate the piston carrier, the thrust washer, and the piston itself. We'll talk about that much more in detail later on. Anyway, so we have lubrication going on down here in the bottom end for the main center portion of that power assembly, known as the wrist pin, the carrier, and the piston. Also along here, that's welded, and this is a 16 cylinder, remember? 1, 2, 3, 4, 5, 6, 7, 8 times 2. We have a 16 cylinder engine here. So let's take a look and see how many main bearings we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 main bearings, or what we call crankshaft bearings. Now, down here they call it main bearing A-frame. And this is a great big piece of structural steel that is welded to the bottom side of this deck plate. That's the bottom side of the airbox. It's very stout, and it has to be, because it's going to hold up a crankshaft that weighs somewhere in the proximity of about 3,650 pounds on a 16-cylinder engine. So as you can tell, each mounting surface has to be welded in, very, very stout. And again, 16-cylinder engine, there's going to be 10 main bearings. And you'll notice, going from the front again, 1, 2, 3, 4, 5. But you'll notice that the 5th and 6th one are a little bit smaller than the 1, 2, 3, 4 in front of it, and the 1, 2, 3, 4 behind it. Well, the reason that is, ladies and gentlemen, is because right here between this 5th and 6th main bearing, there is a flange portion of the crankshaft that actually bolts itself together. In other words, there's actually two crankshafts bolted together, they're bolted here in the middle, that comprise of a crankshaft that will work for a 16-cylinder engine. So you have a main bearing here, and again, where's our biggest stress, if you will? It's usually going to be on the ends, because you got the crankshaft going through here, and again, it takes on a tremendous amount of firing pressure. So we need to make sure that this thing is very, very stout. So again, end plate, P-pipe manifold, main bearing A-frame, and of course, once this is flipped completely upside down and they actually build or rebuild this engine, they will actually go in there and lay this crankshaft. They'll put all the main bearings, the upper main bearings, into all of these journals. They'll lubricate the inside of the bearing, not the outside. They'll lay all those bearings in there, and then with a crane, obviously, they're going to take that crankshaft and lower it into place into all of these. And then again, they'll take the main bearing caps. And by the way, every cap, every main bearing A-frame, every one is line bored. And what that means is that when this engine has been not cast, but when it's been assembled, actually these are cast pieces, but they get welded into here. What they do is they bolt this whole, every cap on every position. And then what they do, they come up with a great big boring machine, and they literally bore the final, or the rough cut, then the final cut dimension for this crankshaft, including the thicknesses of each bearing, including the oil film, which we'll talk about a little bit later. So I have, what they do is, this is number 1 main bearing and main bearing cap, number 2 main bearing cap, and so on and so forth. 3, 4, 5, 6, 7, 8, 9, 10. Now, because they are line bored, I cannot swap number 1 with number 2. Everybody got that? It's really critical that if it's stamped number 1 on the cap and it's stamped number 1 on the A-frame, you do not take number 2 main bearing cap and apply it there and put number 1 there. You have just altered the oil clearances in that. So you need to be very, very careful when you're doing main bearings in this engine to only do one main bearing at a time, and make sure that these things are also what I call polarity sensitive. In other words, there's a front and a back to each main bearing cap, and also that they're stamped. This one is number 1. You need to make sure this is number 1. 2 and 2, 3 and 3, 4 and 4, all the way down to number 10 here. Okay? I think we've covered all that, and this here kind of shows a little bit better picture, shows the beefiness of it, if you will. Up at the top of this A-frame, you'll notice, like I said, it's rather strong, and it has to be. Okay, these parts here are welded to the bottom deck of the crankcase. Remember, this is not a block. And here's the main bearing cap. And remember what I said, they're all bolted together. Then they bring in a machine and they line bore this from number 1 main bearing all the way through to number 10. It's highly, highly, highly accurate, and it has to be. Okay, now each main bearing has what they call A-frame stud bolts. Let me get out of the picture for just a second. Here they are, they're studs, and they'll have a semicircular nut that is actually screwed into or onto the end of the stud, and they actually lock in here in place. There's actually, and as I don't know if you can see this here or not, but it's actually kind of not oval, but semicircular around with a flat area here, and then semicircular around with a flat edge there. So when you install these studs into the A-frame, the two flats or the two line part will actually fit together, and they'll lock in place. Okay? So you have 2 on this side, you have 2 on this side. Okay? Let me see. It says here that a retainer plate located behind the A-frames up here to prevent these things from spinning, and there it is right there. And again, there's that one, there's that one. And then when you get down, and once you get the crankshaft put in, and then you get the main bearing cap installed, then you put the flat washer, and it's a flat washer, and then it's a plain nut, flat washer and plain nut with a proper type of lubricant. Those are spun on by hand, and then they're hydraulically tightened to final torque. Okay, so with that being said, that covers that page. Now, we mentioned we're talking about EMD components, the names of them, what they are, and what they do. When I taught that last class, before I went off out of country, we talked about the front end of the engine. Well, this is the front, and let me just start there. And I'm going to step out for just a second, so I make sure everybody see this. This is the front of the engine, and how do I know that? Well, if you remember from the last time that we taught this class, What kind of components are located in the front end of the engine? Well, we talked about the oil pumps. Here's a scavenging pump, and like I said, I'm stepping out of the frame for a minute. It's a scavenging oil pump. Right inside here would be a main lube oil pump. Where this opening is right here, and there's one on the other side, would be where the water pumps are. Also, we have what they call an engine protective device, or EPD. That protects against low water pressure, and also this protects against a positive crankcase pressure. We also have a lay shaft handle that will go to a governor that will eventually sit on this governor drive. We also have up here an overspeed housing that sits on the front end of the engine, and on this particular engine, this engine is purely MUI, or mechanical unit injection. It's controlled by a governor. The lay shafts go down the side on each bank, and each injector rack is controlled manually at the same time. Now, while we're here, we're still looking at the front. We also, let me step out for just a second, I'll step right back in. This guy right here is what's called a lube oil strainer housing. This guy protects the engine from a lot of the impurities and components that we find in engine lube oil. You know, you would think that the engine lube oil would be pristine, clean, and clear. But if you take that cover off right here and pull this center strainer right here out, at the bottom of that you might find bolts, nuts, washers, trash, debris, all kinds of stuff. Anyway, so this strainer is doing its job. It's preventing all that debris from getting over here to that scavenging pump and destroying that scavenging pump. So, scavenging pump right here, lube oil strainer housing, main lube oil pump right here, water pump here, governor drive here, EPD, or engine protective device, and the overspeed housing. Now also, you can't see it down in here, but also we also have what they call a hot oil device. It's only located underneath the EPD, or engine protective device. The purpose of the hot oil device, and we'll see this again more closely when we get more focused on that system. The hot oil device is designed to shut the engine down if engine lube oil exceeds 255 degrees Fahrenheit. At that point, the temperature is breaking down the oil, and the oil is not lubricating like it should, and we will not run the risk of burning up the rod bearings and main bearings. So at 255 degrees Fahrenheit, the oil dump and the hot oil device dumps down. Governor thinks it has a low oil pressure problem when it really doesn't, but we're fooling the governor. We'll shut the engine down instead of damaging very expensive engine components. All right, so, and I'm also going to step back out of the picture for just a second, and I don't know if you can see this or not, but right here's a little bracket that's mounted on the front of this lube oil scavenging pump, and it's got a little bitty 3-point coupling in there, what they call a spider coupling. And what that spider coupling does on this type of engine for this application, they actually have the fuel pump mounted right here. Usually the fuel pump is mounted on the other side of the locomotive car body over there by the equipment rack. But for this case here, in this particular one, they got the fuel pump mounted right here, which I think is kind of neat. And I don't know if you can see it very well, but right in here is the output shaft for the air compressor drive shaft coupling. It's actually pounded on, and it's an interference fit. When I say pounded on, meaning that it goes on so far, and then they drive it further on to make it a metal-to-metal fit. And then they got a great big nut in there and a locking clip to keep it in place. But this right here is where the crankshaft, the air compressor drive shaft bolts here and goes all the way back, probably a good 6 to 10 feet, depending on the type of application, to an air compressor drive shaft. So it's pretty busy up here in the front end of this engine. Now, let me go ahead and also, just as a quick review, up above here, this is what we call the exhaust manifold system, okay? Now this is a blower engine. How do I know that? Well, if you look right here, I have a blower type air duct, and I have a Ritz blower here, and I have an older style oil bath air filtration system here. And we're going to talk about this one in just a second, but there's a few more things we want to talk about here. Okay, this whole area right in here, and I'm going to come across my own picture, and maybe I shouldn't. I'll just come across here. That whole area, ladies and gentlemen, same thing on the other side with connecting chambers, is called the air box. When this engine's running, there is a whole bunch of air floating around and swirling around here on this bank, also on the other bank, and also to the center bank going from side to side. This is called the air box. Behind every one of these covers is engine air, compressed air from either the blower or in this case the turbocharger. From here down, this is called the oil pan, okay? The oil pan, there's two types of oil pans, by the way. There's what they call the basic, which we're going to see here in just a minute, a basic oil pan, and then there's also an increased capacity pan, which we'll mention here. But what I want to show you right now in this oil pan, you'll notice that there are no gussets here in this locomotive right here, in this diesel engine. It's just smooth metal. If you look over here at this one, there's a gusset here, a gusset here, a gusset here, and also a gusset there. That's increased capacity, and I'll explain that a little bit further in a minute. All right, also we have the top deck covers. There's the latches that either open and close and lift the cover up to get, which you'll see in a minute, to get to the actual top deck of the engine. Back here on the blower type engine, you have a flywheel, and you'll notice that these holes right here are every 10 degrees apart. And what that does, that allows us to put either a manual barring machine or a hydraulic barring machine in a rest right here that's built in the car body to actually open, to bar the engine or rotate the engine. It should rotate in either direction. But wait a minute, we haven't even talked about this. How do I know the proper direction rotation of this engine? Well, the proper rotation of this engine is clockwise when viewed from the back end of the engine, counterclockwise when I'm here at the front. Okay? So it's clockwise when I'm sitting at the back, counterclockwise when I'm looking at it from the front. Now, these little guys right here, just as a quick review, these are what they call compression relief valves. They're a threaded device with a center stem. Some have just the round knurled edges on it. Some have a T-handle that's welded to them. Others like this will just have the knurled one, and it'll also have a hole here and a hole here with a small little test wrench fits in it, and you can loosen and tighten them. A lot of mistakes, a mistake that a lot of the railroad folks do, they think it has to have like 1,000,000 pounds of torque. It really doesn't. With the T-handle on it, that means you go hand tight. Okay? And if it's leaking, well then you just change out the defective valve because there's damage in the seat and the needle. And all the tightening in the world is not going to fix it. So, but if you have that engine running and you hear it leaking going, you need to tighten that up if it'll tighten, or you need to replace that. Okay? Let's see. Top deck area, that's this area right in here. Okay? That's where it holds all the power assemblies, and we'll see that in just a minute. All right, basic oil pan has about 50 to 60 usable gallons of oil in it. And we'll talk about that in a minute. All right, so I think I've covered just about everything here. This is the rear of a turbocharged engine. Remember, this is a blower engine. There's my blower right there. Here's my air duct for the blower. You'll notice this is a completely different design. This is an EMD turbocharger. And just so you know, the small one, just so you get appreciation for the size and weight. If this was a small one, and it's not, but if this were a small EMD turbocharger, it'd weigh about 1,800 pounds. This is a 710 engine, and this turbocharger, I promise you, weighs 2,400 pounds. Very large structure sitting on the back end of this engine. From the center of the turbocharger, where the impeller is, we have kind of a swirl duct here. Okay, you get it on both sides. The air is drawn in, comes into here, comes down into here, goes in the left bank, goes in the right bank. Now, let me ask you a question. What's the temperature of the air coming in here? Let's say it's a nice, balmy spring, or not too hot morning. Let's say it's 70, 75 degrees. That's the temperature of the air going in. By the time it goes to the impeller and gets compressed one time, goes through this swirling shape of the turbocharger, by the time the air hits the front of this aftercooler, the temperature has risen to over 350 degrees. That means that the air there is so hot you could actually bake a cake in front of that aftercooler. Of course, not you never would, but that's how hot it is. And that's the reason why we have these aftercoolers in there, is to draw that heat down to a usable temperature. We're going to take that heat and knock it down into this air box down to about 180 degrees, which is a little bit better than half, which is pretty good. So, turbocharger, again, we have a flywheel, just like the flywheel we have here. The only difference between this engine and this engine, turbocharger here, blower here. This one here is probably putting out, I don't know, probably 1,500, 1,800, 2,000 horsepower. This guy right here, it's a 710 G3B, he's cranking out 4,300 horsepower. So you can see this guy's putting out almost twice, if not twice, the horsepower of this guy. Again, exhaust manifold here. The exhaust manifold is clearly different on the 710 or turbocharged engine. We have the top deck area, which is very similar to the top deck area here. Again, similar or same air box. Remember, this is the air box section. And down below here is the oil pan. That's where all the engine oil will be. And that's where all the connecting rods and the crankshaft rotates around. Flywheel in the back, like we mentioned, but the cool part, this engine here has two starters that engage in the flywheel when we start this engine up. Now, remember earlier we talked about a basic pan, and you'll see it here in a minute, but I want to show you something really cool and how you identify that on a basic pan versus an increased capacity. Remember what I said earlier, you look for the gussets. There's 1, 2, 3, 4. That's to give that oil pan extra strength, because this oil pan, the increased pan is going to go from the corner here all the way back to the back end. That's called the increased capacity. This has 150 gallons of usable oil. This one has about 50 or 60 gallons of usable oil. Okay? Again, blue ball strainer housing right here. Turbo filter right here. Additional filtration for the turbo. We'll get to that when we talk about blue ball system. I don't know if you can see it very well, but right here is a little panel. And that little panel that bolted on is called an ECM, or electronic control electronic control module, excuse me. And what this means, that this locomotive here has electronic unit injection, or EFI, electronic fuel injection. This guy here is strictly manual with a governor. This guy is much more accurate in delivery for pressures, fuel pressures, also for horsepower. This one is not nearly as accurate because it has a governor. And again, like I said, it has lay shafts on each bank, and it's limited in its ability. And we'll talk about that when we get to the fuel system. I think we've covered the differences and also yet the similarities. All right, let's go to the next one. Okay, so now we're inside the top deck. Go back for just a second. See this cover right here and here, or this cover right here and right here. All right, let's go back. Once you open up that cover, when that's the very edge of it, you will see something very similar to this. So, when you raise that top deck cover up on each bank, you're going to get something that looks similar to this. Now, this is an MUI engine. How can I tell? Well, first of all, there is that little lay shaft mechanism right there. So I know this is a mechanical unit injection. Also, I see the shaft that goes down here. And by the way, this is number 9 power assembly, because that's where the lay shaft handle is. You got number 9, 10, 11, 12, all the way to 16. I have an injector rackage link, which also lets me know that this is a governor controlled engine. Okay, but let's talk about all the components inside here. Let's stop way back at the top in the corner. Way back over here, this kind of an oval looking shaped thing, bolted to the front end and also bolted to the back of the engine, is what we call an overhead camshaft. This engine has 2 of them, left bank, right bank. These camshaft rotate opposite each other, and they operate 3 different rocker arms. This is what I call an exhaust valve rocker arm. The middle was an injector rocker arm, and the one on the other side is an exhaust valve rocker arm. Right here is what they call a valve bridge. And a valve bridge, the reason they call it a valve bridge is because the actual bridge bridges, if you will, bridges to exhaust valve with one device, otherwise known as a valve bridge. Okay, so it's a valve bridge. I have a valve bridge here. I operate 2 valves with 1 rocker arm. I get the same thing on the opposite side, and in the middle, I have an MUI, or mechanical unit injector, right smack here in the middle. Speaking of the fuel system, also I have what's called a fuel hose, or fuel pipe, okay, or fuel line. And here's the cool part. When this fuel comes running into here, this top line, ladies and gentlemen, is supply. All fuel that is not consumed in the injector must travel through the injector, come back up, and go through the return line, which is the bottom line. So this top line here is supply, the bottom line is returned. And all the fuel that goes to every injector in that entire bank, on each bank, the fuel that is not consumed in the combustion or firing of that cylinder is used to cool and lubricate the injector, and then it comes back and flows back to the tank, the fuel that's not used. Okay? We have hold down crab studs. This is what they call a single crab assembly. I've got 1, 2, 3, 4. I don't know if you can see it well, but right in here is what they call a head firing ring or head seat ring. It's made out of brass, and on the newer ones, they actually have a green Teflon seal that fits right here. The important thing here is to make sure that when you put this power assembly in, that we have even contact between the single crab and the cylinder head, so we don't have one side with most of the metal and the other side with just a little bit. If you do, you're going to crack the cylinder head. And there is a way to properly torque these, which we'll talk about much later. Again, this is the lay shaft arm that comes in. This lay shaft arm moves back and forth, which moves that injector metering rod in and out. Also, remember we looked at the crankcase the other day. I said there's 4 places on this where the crab nuts will fit, and right here on the end is a good example. There's actually a machine area that this crab sits on. It's kind of stepped up where that fits there, so it fits in the head as well. Those are 2 of the 4 for each quarter section of the engine. And remember we talked about the quarter section, we got to the middle, there's 2 great big areas. That's also used on the 4th power assembly and on each bank. All right, back up one more time. Let's just make sure that I've covered everything. This little handle is a compression relief handle. Here's our top deck cover safety latch. Locks that down, because you got to remember, when this engine's running, do I have a vacuum or a pressure up in this area? Because it does make a difference. What I have here is a vacuum. And we'll talk about that much later when we get to the crankcase ventilation system. This hole right here is what they call a head puller hole. There's one here. There's one also on the opposite side. We talk about troubleshooting, which we will down the road. By pushing that oil out and we find fuel or water, is that going to be a problem? Okay? I think that just about cover. Oh, one more thing. Oil line comes off the camshaft, comes down through this line. That line feeds the rocker arms right here in the center shaft. Then that oil goes down through a drill passageway in each rocker arm, and it goes up and lubricates the rocker arm rollers, and also lubricates the ends of the rocker arms here. And splash lubrication on the injector arm actually lubricates all the external parts of the injector. Oh, a couple more little things here. This here is a saddle that the rocker arm shaft. There's a bottom one or a lower one and an upper one. Put those in wrong, you'll break them. There's a trick to watching that, and we'll talk about it under EMD power assembly change-out. Also, you don't even see it right now, but there's a number 3 right here, which means this is a number 3 type cylinder head. And also these studs right here with the nuts on them, those are cylinder head to liner nuts. They keep the head and the liner assembled together as one unit. All right, I think that just about covers that. Let's go ahead and go to the next slide. Inside the airbox. So we get on the engine and we take this cover off, pull it aside. And by the way, you don't want to take that, you don't want to loosen that cover off too much, because if you do, you'll run the threads of that center shaft off, and next thing you know, the bracket that fits across here, now you're going to have to pick it up and put it all back together. Done that a million times. Anyway, this great big large tube, what they call an inlet water manifold, that goes from one end of the end plate of the engine clear to the other end. It's about a 4-inch diameter pipe, pretty good size. That allows our water to flow and deliver the water to each power assembly. And this shows a really good shot. There's a jumper connection right here. Water comes in, comes up, and goes into the center of that opening. Behind that flange surface is what they call a water deflector. If you're going to change this out, you got to make sure that water deflector is in there. If you put that power assembly together and that water deflector is not in there, you will crack that liner. You just made a $3,500 mistake, or more, depending on where you're buying your power assemblies from. So always make sure that water deflector is in there. Again, here's our liner. There's the piston. And you'll notice, and I mentioned this, let me mention it now. These here are the ports. 2 very important things when you talk about the ports. Number 1, first of all, they're not straight in. When you look at them, they are not straight at you. They're actually canted 12 degrees to the left as you're looking at it. Why would they do that? The reason they do that, as this air is swirling about inside the airbox, the air that comes in at its best angle, and we get the most maximum amount of air into that assembly, into that combustion chamber, with these liner ports slanted just a little bit. Another thing, as the water is flowing in here, there's this lower liner jacket where cooling water is flowing all around. Then where each one of these liner port columns is right here, there's actually an 1/8-inch drill hole which allows the cooling water to go 360 degrees around that and flow from the lower portion to the upper portion, where there's an upper band, if you will, of that liner. And then from there the water goes up through drill passageway up into the cylinder head, then out through the cylinder head discharge elbow. This line right here is what we call a top deck drain. That takes engine oil from the top deck where it drains out and it sends this back into the oil pan. And by the way, can anybody tell me why you look at most of these EMD engines and I see a lot of carbon in there? Well, that is just a normal product of the combustion process in here. And later on down the road, we're going to talk about how that carbon gets in there and what other element is in there floating around inside this engine. Okay, let's go to the next one. Last but not least, inside the oil pan. As you can see, it runs the full length of the engine, whether it be a basic pan or it's an increased capacity. Here's the cool part. There's 1, 2, 3, 4, 5, 6, 7, 8 openings on each side, which means we have a 16-cylinder oil pan. But I want you to look at is right in this area, right in here, right here to right here. This is what they call a basic pan for two reasons. Number one, it holds a very small amount of usable oil. And the second thing is there's no gussets here. That's how you can tell if this oil pan is basic oil pan or increased capacity. This oil pan holds somewhere between 50 and I'm going to guesstimate 65, whereas the increased capacity holds 150 gallons. Also in here, right down this area, right in here is an open area, and this great big area here, the oil is drawn in through this 4-inch tube, and it goes out here, and it goes out and connects to the lube oil strainer housing, where it's going to draw the oil out and get cleaned up for use in the engine. So anyway, so we did a quick review of the crankcase. We also talked about the airbox, the top deck, the main bearings, the crankshaft. Then we opened up the top deck cover. We looked at all the components on the top end of the power assembly. We also looked inside the airbox, and we also looked inside the oil pan. Remember, if you're interested in our classes, go to our website, www.lst-ca.com, and take a look and give us a call. Thank you and have a safe day.